Welcome to this tutorial for the PCB Essentials, the basic concept in PCB design. This tutorial will help you to improve how to create a professional way of making the printed circuit board. My name is Jinto Bijoy. Join with me. Let's started. Okay, the PCB stands for the printed circuit board. It is a copper laminated non-conductive printed circuit board. And all electrical and electronic components are connected together in a one common board with the physical support of all components with the base of the board. Okay, which means that it gives electric connection of your components, and the physical support of all the components is on your board. Yeah, and which gives to allows to flow the current of one component, one pin to another pin, or in your circuitry. It's allow you to communicate. It's giving the connections, electrical connections, provide electric connections together. Yeah. Okay, if PCB is not should be there, you can do with the same thing as connect the your component the pin one by one, or to connect by the wires. That should be we can do with equivalent, but it should be inefficient, or it should be very complex and the decrease reliability of circuit. Like that way we couldn't make like a bigger boards like a motherboard or very complex board. We should not have to create like that. And every electronic equipment they have to see this is a printed circuit board inside it. Television, mobile phone, digital camera, computer, and application like medical applications, industrial machinery, automotive industry. PCB design is not just a connections of wires. It has a lot of calculations to do. Each and every path is required the current density, or the calculations of how much current will flow through it, or how much spacing should provide for each lines, and many calculations are inside it. So it's not just creating lines. Okay, printed circuit board, it's a art of handling the components. Like it's providing the all components together and making very shortest communications possible, and very high reliable, and very highest thermal withstand, and many more factors that are affecting on a printed circuit board when creating. The designer are very struggle to design in a faithful and very accurate and reliable PCB. For making is very difficult. Mistaking a lot of factors is what they are doing. Okay, different types of PCBs are available: single-sided, double-sided, multi-layer, rigid PCB, flex PCB, and the rigid flex combination PCB. Yeah, as we all know, the single side PCB, the name implies there is only one side of the copper layer established. The connections of the connections is takes place on the one side. The components we get holding on the one side. Okay, which is and very low cost, and very easy to manufacture, easy to design. Printed circuit board is a single layer. Okay, the many low cost applications we're doing for the single, which is the choice application and switched mode power supplies, uh, and very shortest application. So very quick we can build this single sided. The much more that when there is also using the low cost and bulk manufacturing application that in our company they're continuing they're doing. So, okay, these are the low cost PCBs, and which are using for bulk manufacturing applications like calculators, radio, printers, switch and more power supplies. It's all doing the single side PCBs. And the double side PCB, as the name implies, is a sandwich. It's like a the two copper layers are available at top and bottom, and the center part is called the core or a substrate. And the PCB material is FR4 or some other glass epoxy, or different components should be there. Different. Okay, the double side PCB, as we all know, the two sides are conductive and one inside layer is non-conductive. Okay, copper on the both sides of the board. This board is considering via. Okay, in two layer, the two top and bottom should be connect through the via. It should be relatively low cost. The most important that advantage of the two-layer PC, double layer PCB is reduce the size of your PCB, and that's why should making more compact. If the single side PCB is taking much large components, a much large space, because there's only one sided of components. It has two some border. There's both sides are contacting, so we can reduce the components by assembling in the two layers of the board, the top and bottom of this board. And multi-layer is comes under the stack up position, like it is a sandwich company. It's a multi-layer. Three or more conductive paths or the conductive layers are possible in a multi-layer. Very complex processes are creating for the multi-layer, and the medical equipment like file server and data storage servers, that should becomes under the multi-layer session. The multi-layer, the layer arrangements is called a layer stack up. Each and every the 4 layer, 6 layer, 8 layer, every um design its own have its own stack up. Okay, rigid PCB is made from solid material, which cannot allow to PCB from twisting or bending. We cannot twist or bend to do this rigid PCB. Okay, that comes under the new one. The other one, another one is a flex PCB. It's also called a flex circuit. This type of PCB is used for flex materials. This type of PCB used flex material like a polyamide, PEEK, either catron, or transparent conductive polyester film. Or another one is cameras and light emitting diodes, LED strips. That's all making flex PCB. The rigid, another one is a rigid flex combinations of PCBs. Many applications are there. Both the half in some parts of this PCB is a rigid one, and another part should be the bend that is flexible. Okay, we can see that when your the mobile phone display or touch screen, that should comes under this rigid flex combination PCBs. Okay, then each and every electronic equipments are considering in a IPC classes and IPC performance. IPC is a organization uh, which is uh, which is for research and R&D, research and development for the printed circuitry, and how to creating a reliable board, how to creating making the better performances board. Like they are researching in institute for the printed circuits. They're the company, their organization's name. Yeah, they are defined into the electronic material are into three classes: the class 1, class 2, and class 3. Class 1 is a comes under general electronic product. Our lowest quality requirements is possible. Yeah, is making just like toys or something, that should be have very lowest requirement, quality requirement, and short life cycle. The most inexpensive, that comes under most inexpensive, that comes under the class 1. It's a very low cost toys. It's like a small electronic products, just comes under the class 1 product. Yeah, another one is a class 2 product. It's complex. It's a dedicated servo services electronic product. Yeah, it is a high performance in external life. It's a it's very high. It's a high performance and extended life, long life cycle, and higher reliability. Yeah, it's a better performance PCBs are the content under the class 2, and high reliability is also they provide. Yeah, the class 3 is a high reliability electronic products, very high reliability, which means it never fails. It's a it's never fails in different temperature or any other conditions. It should perfectly work at some many magnetic interferences or comes under. This board is highly reliable to work. It is a uh, it's highly immune to the noises. Everything comes in the class 3. Okay, let's these are the classifications of the classes for the international, the institute of PCB, the PCB for the institute of printed circuits performs. Okay, now let's compare the different classes. As we see, that's a class 1, class 2, class 3 is shown here. Okay, the life cycles of the class 1 is very short. The IPC class 2 long, and IPC class 3 is a very long. Okay, the quality is cheap, good, and fail proof. Yeah, there's a, we can see this highest quality product is a class 3. It never fails. Okay, just like the application, like a medical application, it's like a, when you're making the pacemaker, it is a devices which connect inside your human body. So it should not be, it shouldn't fail, never fails. Okay, there is a no possibility of to making it failure. So the like aerospace, military, that comes under very high quality product. Yeah, then we that comes into the class 2. There's laptops, microwaves, and some mining equipments and stars comes under the class 2. Then, as we all know, the IPC class ones are toys, flashlights, and smartphones. The smartphones is also comes under the class 1, because its time durations of the working is counted, or is made for 2 or 3 years. Is maybe the smartphone for design. Yeah, for limited durations of work cycle. Okay, so in this the tutorial and in this class, the PCB creating is not just a it's not a simple way to create, because you have a lot of factors are affecting inside, lot of constraints are we need to use. Okay, so many EDA tools. EDA means electronic design automation. Yeah, electronic design automation, which lots of tools are available. And Ultimate Designer, Cadence, Allegro, KeyCAD, OrCAD, Eagle, Zuken, pads, ECEDA, and Expedition, many more that are using uh, any tool we can use to create your own boards. Okay, let's discuss with the steps in a design process. When you complete from top to bottom, there are few more steps to we're going to go with a few more steps, is like here. The first thing is, first we create the schematic capture. Okay, we can create the schematics by using the schematic capture tool. You can build your schematic by your simulations, by the help of the simulation, or you're directly taken from your internet, or you run the design you can do with the schematic design. Okay, then after the completion of the schematic, we should have to creating the preparation for the layout. Okay, the preparations means we can convert your information into their net listing. It's called the net list, or and creating the bill of materials, like the conversions takes place for. Yeah, that's for the second step. The third one, basic setups of the constraint. Okay, this constraint is a basic rules the creating the PCB. For example, the trace width should be manufacturers, the trace should be 0.15 for the minimum, creating the manufacturer's feasibility. Yeah, that should be, we can enter like a basic constraints on it. Then we start to creating the layout. That comes in the layout section. We should do with the placing of the component. The placing is a arrangement of the component. Just to properly we arrange the component. If the placing is good, your communication and everything is perfect, works perfect, and their connections are making much easier. Yep, the placing is a very important point in the layout design. Okay, then after the placing, there comes under the routing section. Connect to the route, correct its traces, everything. Okay, yes, the next one is to prepare for the manufacturer. Yeah, the manufacturers requires their own. Okay, the when we creating the PCB board, the PCB, when you're creating the layout on a specific file, the created on the board file .brd, the extension. Okay, for sending for the manufacturer, for creating the PCB, there's require Gerber files. Gerber file is just nothing. It's a specific layer. It's a layer file. The layer of our design. Yeah, as a layer, which top layer, bottom layer, inner layer, silk screen layer, solder mask layer. Much more layers are we going to creating on the layout. Okay, that's the name is called the Gerber file, and also have one attachment is called a drill file that should have also attached to it for the Gerber file. These two informations we send to the manufacturer. They're creating the board. Okay, the last one is for the generating and documentation. Generating documentation. As a PCB designer, the two things they have to do. One is for the document, the PCB, the bill of materials, or the documentation of your board, documentation of your PCB display. Everything you can creating by the PDF or convenient format. The last one is a submit PCB files for the fabrication. Yeah, these all the steps we can follow. If you follow to the everything step, these for all the steps we can follow to creating a PCB. Yes, and each and everything we can discuss in later. Okay, basically, as we all know that previously mentioned is a netlist is what is a netlist? Netlist is means basically the information of your net. You can see here is a four nodes. Electrical nodes are shown. One is for ground node, one is for here, sorry, one is for here, and another one is here. The four nodes are well, references of one node, and the component b1 and r1 is a between there is one node existing, and r1 and d1 there is a another node is existing. One, two, three nodes are available. This information shown into the right side, a text file. Basically, it's an ASCII file which have correctly the replications of written program, the correct replications of this circuit into the written form by the ASCII code or ASCII naming. All the informations mentioned as a name of nets. That's called a netlist. Yeah. Okay, for example, there's a b1 is a 6 volt. The b1 is a mentioned like a mentioned connector into the 6 volt net, like that. R1 is a 330. Okay, so it's a part ID table and net tables are available. Net 0001 is a 1, ground is a third, and N002 is 5. Okay, there are the net namings table and the reference ID table. They're making an ASCII version of exact replications of the coded form of order schema, net order schematic. It's called the netlist. Okay, let's see to that here. There's a basic board structure of a PCB. Here we can see it's a single layer board. There is only one copper layer inside it. Okay, you can see this yellow is a copper layer. The copper power on it. Okay, the inside, it's the copper layer attached with the substrate, which is a FR4 material. Is a that is a basically it's a copper, basically the PCB material. FR4, FR1 to FR2, and the different materials are available according to your the PCB requirements. And the solder mask is a very top non-conductive part, which which shows the references of our each and every component on. This is called this is called single layer PCB. Like that double side PCB, the two copper layers are existing, top layer and bottom layer, and the inner there's a substrate material, which is like a sandwich top and bottom, and inside substrate like a sandwich connection, and it has the top solder mask and bottom solder mask are also existing. Okay, so this is a multi-layer PCB, which is the stack up for four layer PCB. Like it have a top layer, bottom layer, mid layer 1, and mid layer 2. Okay, you can see there is a green color microstrip. It's called the microstrips. The connections are one connector to another is there's a going track is called the microstrips, and you can see there's a cross section of a wire. The cross section of every tube is like a copper tube. You can see this is called the wire, which are connecting one layer or one microstrip to another layer. It is doing a connection between the one layer to another. It's called the via. Okay. In right side there is shown the prepeg, core, and prepeg. That are the different kinds of material using for creating the PCB. Okay, then we comes under the different types of material. Okay, FR4 is means is that fire retardant, like the fire retardant material, like that's called FR4. The most common glass laminated material is FR4. and it's based on woven glass epoxy compound. It supports a good mechanical strength. FR4 is a mid material, is a highly insulated, and it have a specific dielectric constant of this material. It's a based on the woven glass epoxy. Everything is a glass epoxy materials. Okay. Another one is FR1 to FR2. These are the material paper and phenol. It's used only for a single life PCB. Okay. And the polymidi is another one. It's using for the flexible PCB. The polymidi materials made from the Kapton, Roger, DuPont, etc. That's for the polymidi. Pre-pack. Pre-pack is a special material. It's mean actually the pre-impregnated. Impregnated. This is called the pre-pack. Okay, it's a also fiberglass impregnated with resin. Okay, pre-pack adhesive layer which gives strength similar to the fur. Okay, it's a very cheap material. It's like a compared to the core. Yeah, that's all for the PCB materials. Okay, the next section is comes in the via. Via is basically is connected to one layer to another or one microstrip to another. Okay, it gives a definite current, provides to gives the path from one layer to another. Okay, and you can see also the reference plane is there, and anti-pad is there, and everything. This is a basic structure of a wire communication from top layer to bottom layer. Okay, the anti-pad is insulating with the internal layers from that the wire connection. Okay, so here we take a look that what is the output or what are the document we send to the manufacturer. These are the outputs when we creating after that layout production. Okay, one is for the top dot art. This is comes under the art format, RS274 format. It's a top layer, bottom layer, fabrication layer, and silk screen top, silk screen bottom, solder mask top, and outline and project name .drl. These lines is these. This is an example of two-layer PCB. If the layer is increased, these the files is the number of these files are increased. When it's a multi-layer PCB or 6 layer, 8 layer, that layer namings is minimum get 8 numbers, like a top, inner one, inner two, inner three, like that will have 8 numbers. Then other supportive like a silk screen top, solder mask top, that's comes under again layers is are mentioned. Okay, that's all for the final product output. Okay, let's have to comes under the IPC 2221 A. Okay, IPC we all know that's the Institute of PCB, the Institute of the Printed Circuits, which this company with the organization, this institute to research and creating that the quality document, the creating the standard document for internationally accepted the PCB creators. Okay, they are they defined the specific some the rules to creating the details of the spacing. Okay, the details of which the spacings of the conductor which withstand different voltage levels. Okay, here is a conductor spacing details. Okay, you can see the B1, B2, B3 for the bare board, and B4 also, and the assembly versus are okay. That all are mentioned in down B1, B2, B3, B4, A8, 5. Okay, so these are how much voltage levels it can handle with each PCB. For example, the B1 is an internal conductor. If our voltage is comes under 51 to 100 voltage, we choose the zero point 0.1 millimeter for the spacings for internal for 100 voltage up to the 100 voltage peak. Right, this is a zero point 0.1 millimeter internally. Yeah, um, this is very helpful. This is very help you to creating the PCB designer. Thank you for watching. Thank you.